into the next chapter, I think I have to cover this part, but I just focus on the main thing of this lecture. One of the topic on the subject is on tomography. Uh, Tomography is one of the topics. We will look into the basic of tomography system, image reconstruction, and then image and then the other factor in tomography, and then sensor design and sensor performance of the tomography system. Uh, I think not this one. I will check. Okay, I'll go through this one. What is basically tomography? Tomography is basically a process where we can estimate the condition inside the pipeline. So the idea is have a pipeline. So a pipeline may transfer material. It can transfer multi-phase, the combination of liquid plus air, create bubbles, or liquid plus solids, or air plus solids. So with the tomography, what we want to do is to have a capability to check the condition inside the pipeline. So in that sense, few things that we want to see is the concentration in form of image. Okay, the image concentration of the pipeline in form of image, and then from there we can estimate the volume flow rate, the mass flow rate, the velocity of the flow basically. So what is means by tomography? It means that slice of a picture of a slice basically. So tomo to slice basically with or picture of a slice. Okay, so a slice of a picture basically. So it's basically want to obtain an image uh, of the cross section image of an object. So we want to go with, look into through the object. Okay. So the idea is to see what is inside the object without having to actually cut the object. Okay, physically. So it's like in the hospital. Okay, you have the X-ray. So X-ray is basically an estimation of your internal body at one plane. So an X-ray, let's say it check your hand. So it's actually an impulse figure of the slice of your hand. Okay, but in tomography, we want to take uh, one part of the slice of the picture. So how it done is by installing a number of sensor around the pipe. Okay, we install a number of around sensor around the pipe at a certain point, and then we get the information, okay, like the concentration profile, and then volume, flow rate. But before we get volume flow rate, we have to estimate the velocity. Okay. And then from that, we have the information of the concentration or the volume flow rate. We can use that as a control measure, measured output, okay, feedback to the control system. And therefore we can have a measurement to control the flow of the material inside the pipeline. Okay, the tomography system is categorized into two main fields. The first type is the hard field. Second one is the soft field. Okay, hard field is basically set up a uniform narrow which the sensitive independent of the parameter distributed inside the sensor. Hard field means that the sensor is not sensitive to the position. The sensitivity means that the energy travel, okay, to through the pipeline is not sensitive to the uh, parameter distribution inside the pipeline. For example, okay, if we have a pipeline, a cross section of a pipeline, so we install an optical sensor, let's say IR transmitter, and on the other side is the IR receiver. So the path of the IR radiation when it travel through the inside the sensor, so the path will not basically have not sensitive to the material. Means that uh, the field path is not sensitive. The field path is not basically sensitive to the material. For example, if you have a semi-solid material, okay, the path will not change. It will stay at the original path. Only the level of the intensity may reduce due to the semi transparent material, okay, or that is in between the transmitter and the receiver. But the path will not be sensitive. But for soft field, uh, basically it's sensitive. And but before that, the other type of hard field sensor is like positron imaging tomography. This is radiation, so the energy in hard field normally straight. The field path of the energy from the transmitter to the receiver is usually straight. But for soft field, let's say one of the is capacitance tomography. Capacitance, we have two plates, let's say on the cross section of the pipeline. So we install positive, negative. So the path, sensitive path of the energy, okay, is like a electric field. So when there is an, let's say, an object with high permittivity, okay, here high permittivity, so the field path, okay, will change. Okay, the field path or the sensitivity distribution will be influenced okay, by the material distribution. So that's the difference between hard field and soft field tomography sensor. So the tomography started in medical field. What you have in the hospital, okay, if you ever heard of the concept of uh, CAT, CAT scan, so that is stand for computed aided tomography. And also like the MRI, magnetic resonance imaging. So that is basically using the same concept of tomography to get the cross section image of our body, so they can manipulate the plane. Okay, that's a much complex system. Okay, by manipulating the magnetic resonance imaging field. So this is an example CAT scan. Okay, so there's a set of sensor. Okay, at 90-degree angle of the object. Okay, so this is the angle of the object. So the sensor is basically placed exists on around the object. So having this system, so we can estimate the slash picture of the human body. So the scanning is done, okay, by taking a set of measurement, okay, at different angle. Okay, they have many angles. So from 0 to 180-degree angles, and at every angles, it will do a multi-translational scanning. Okay, let's say from 1 to 32 location. So let's say at 0 angle, so it will make a measurement from 1 and then move the source and receiver in parallel to the second spot until we complete 32 measurement. Okay, and then move on to the next angle plane to 1 degree and repeat. Okay, the translational angle translational measurement 1, 2, 3, and until finish. So in this scan is happening in a very in 5 minutes. Okay, for example. So that concept, similar concept, evolve, okay, into the uh, process tomography. Okay, instead of having using the X-ray, the process evolved to using sensor like optical, okay, and electric capacitance, electric charge, impedance, ultrasonic, microwave, and then other hard field source like positron emission. Okay, so the difference between the medical and process tomography is that in process tomography, the imaging process is much faster. The time it takes for the process tomography is much faster, but the quality in process tomography is less than the medical. Why in process tomography we need to make the measurement very fast? Because the material that flow inside the pipeline is moving very fast. Okay, example of the uh, process tomography used in the oil field to measure, okay, the amount of concentration, in that flow through the pipeline, okay, to then monitor the flow through the pipeline using the process tomography. Okay, I think and then the process tomography also can be used to measure the mass flow rate. So basically from volume, velocity, flow rate. So we can measure the uh, volume velocity if we know the uh, cross section area, and then we can measure the mass flow rate. Okay, if we know the mass, the amount of mass or concentration. I think this is an example of process tomography to measure the flow rate of uh, solid particles. Okay, whereas the sensor is placed around a pipeline. So this system basically carry solid particles around 3 mm size, and then the particle is transferred into the hopper, and the valve is open, so the material will drop uh, uh, and drop with the gravity. So the system here, the tomography uh, sensor is installed around a pipeline at this plane. Okay, and the system may include a data acquisition system. Okay, and 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 what is inside the tomography system? We must have the sensor type of sensor. This is the type of sensor array from the hard field and soft field like the optical, soft field like the capacitance, and then the signal conditioning circuit uh, to translate the output into voltage. The output of the sensor into voltage converts the energy, okay, from optical, for instance, to electrical signal, and then capture the output, and then the signal is captured through the data acquisition system, and from the set of signal retrieved from the array of the signal, they use a image reconstruction algorithm, and then from the reconstruction algorithm we get the concentration profile. Okay, the concentration profile. Okay, showing the density inside the pipeline, for instance, on our computer. Some of the image reconstruction algorithm uh, use typically is like the linear back projection. Okay, so linear back projection basically the sum of the image at different plane, okay, uh, imposed together basically, and then there are other image reconstruction algorithm. So this formula basically shows, okay, the how the reconstruction is done. Basically, what is first thing that we need to estimate is the uh, okay, the output. Let's say let's say, hang on. Let's say we divide the concentration the concentration plane of the image, which represent the concentration path of the pipeline, okay, by 4 by 4 pixel. Okay, so we need to estimate what is the distribution of the output, let's at every plane. Let's say for output for the first plane, okay, so we have a set of measurement, and then the second plane, okay, we get also the distribution or the on the plane, okay, and basically the final image is the sum, okay, of the uh, concentration uh, retrieved from each sensor output, okay, and that the concent so the let me show you some example. Okay, this is what basically linear back projection and filtered back projection what we get. Okay, for instance, the reference image, okay, the what you call as the phantom image, where the object is on the left side, and using the linear back projection, so that we get that this reconstruction image. So in this application, maybe it is install multiple projection, okay, on the plane to estimate the output. So as you can see, the linear back projection uh, is the result of the impulse of the output output from each plane. So as you can see, there are some smearing effect. Okay, so the concentration from 0 to 1. 1 is the darkest or color, showing estimating the object is on the left side of the plane or the image plane. Okay, so there are like filtered back projection method also having some the ability to estimate but just in the filtered. As you can see, the image position is much accurate as compared to the reference image. So this is an example of the outcome using the process tomography, where it can be used to estimate the position of the solid object, one object. So in the actual process, there will be multiple or many solid material at different location. So it can be used to estimate the condition inside the pipeline at a certain cross-section area. So basically that is process tomography. Okay, and next we will go to the uncertainty and probability. But I think we take about 20 minutes break, okay, before we continue